Welcome to a new lesson. In this lesson we'll be discussing slopes of parallel and perpendicular lines. Let's first define what a parallel line is. Parallel lines are lines that extend forever and never meet. Slopes of these two lines are equivalent. For example, we could have a slope of a third, that's slope 1, and we could have slope 2 is equivalent to 6. Both of these are the same and parallel slopes. Perpendicular slopes, however, are not equal. They meet at a 90-degree angle. Their special property is that when they're multiplied together, slopes I mean, you'll get a value of -1. And they're also negative reciprocal of one another. Meaning, if I had a slope of a third, that would be my first slope. A negative reciprocal would mean that the 3 and the 1 would switch spots. So slope that's perpendicular to it would be 3 over 1, and that the sign of the slope would be opposite of that of the original slope. So the slope would be -3 over 1. Let's use this information to answer a couple of the next examples. The first example, line GH passes through point G and H, line JK passes through point J and K, and line MN passes through the point of M and N. Sketch the lines, and the question is are they parallel? Justify the answer. So here we go. We've sketched these three graphs, and it's not clear whether they're parallel from the graph. If we extend the graphs to the left or down up, we are not really sure if they are crossing. So because of this, we have to use the slope formula and prove that these slopes are different or the same using the slope formula. Recall that the slope formula is the difference between y2 minus y1 and x2 minus x1 is the ratio between these. So let's first find the slope of line GH. In order to do this, we first have to label GH. x1, y1, x2, and y2. And now use these informations to insert it into the slope formula. So we get -1 minus 2 over 2 minus -4, which is equivalent to -3 over 6, which is 1/2. So now we know that GH has a slope of -1/2. Now the next part is to solve for the slope of JK. Again, we need to label it x1, y1, x2, y2, and we plug it into our slope formula. So we have 3 minus 7 over 7 minus -1. On the numerator side, we have -4 over 8, and therefore we have -1/2. So that's m. So now we have a slope for JK of -1/2. We'll do this last thing, the same thing for finding the slope for M and N, line segment. As always, find the slope first by labeling the coordinates points. So we have x1, y1, and x2, y2. Now we can plug in those values into our slope formula, and we have 1 minus 5 over 5 minus -4. Numerator we get -4, and denominator we get +9. So now slope is going to be -4 over 9. So the question is that which of these lines or slopes are parallel? And the only ones that are parallel is this one and this one, and it's because the slopes are the same. So we have the finishing statement, therefore, that's what these 3 dots mean, JK is parallel, that's what that 2 lines mean, to JH because of the equal slopes. Let's take a look at the next example. We have line PQ and we have line RS. Are these two lines parallel, perpendicular, or neither? And justify the answer. We're going to sketch the lines to provide the answer to part A. Well, I'm going to sketch this first. So here's the sketch, and it looks to me that they're not parallel because if we extend the lines, they will cross eventually. And they're not perpendicular because they don't cross at 90 degrees. But we need to solve this using algebra and using the slope formula. And here it is. The first thing we are going to do is going to label for PQ their coordinates. So we have x1, y1, and x2, y2. And now we're going to plug this into the slope formula. So we have 10 minus 2 over negative 2 minus negative 7. 10 minus 2 is 8, and negative 2 minus 7 is negative 9. Now I've just made a typical mistake that everybody makes. Let's take a look where this mistake occurs. We have negative 2 minus, and now the x1 value is actually negative 7. So we are actually going to be adding negative 2 to 7, which is 5. This is actually 8 over 5, the slope. Now what we're going to do is we're going to find the slope of RS. Again, you need to label R, x1, y1, x2, y2, and plug those values into the slope formula. So 1 minus negative 4, and we have 5 minus negative 3. So we have 1 plus 4, which is 5, and 3 minus negative 3, which is 5 plus 3, which is 8. And notice that 8 over 5 and 5 over 8 are not equivalent, so they are not parallel. And because they're not negative reciprocal, they are reciprocal of each other. It means 5 and 8 have reciprocated, but they both have the same signs. This is positive and this is positive too for slopes. So they are not perpendicular. So they are neither. And we should have those 3 dots. Therefore, not parallel, not perpendicular, so they are neither. Let's take a look at the next example. Determine the slope of a line that is perpendicular to the line through E and F. Determine the coordinates of G so that line EG is perpendicular to line EF. Now, I've shown you a picture, and we're talking about perpendicular lines. So for the first thing we need to know is the slope of line EF. Once we find the slope of EF, knowing that what a perpendicular value of the slope will be is negative reciprocal, then we could change the slope of EF to find this perpendicular line. And let's do that. And the first thing, of course, we have to label x1, y1, x2, y2. And now we have negative 1 minus negative 4. And we have 3 minus... you have to be careful when you are putting these in. Let's try again. Negative 1 minus 3. And we negative 4 minus 2. So our slope turns out to be negative 4 over negative 6, which is 2 over 3. That's the reduction part, dividing by negative 2 to get that value. Or negative by negative is positive, and then we just divide by 2 both sides of the fraction. We say 2/3. Now, the perpendicular slope will be 2/3, would change it, or reciprocate the slope, which is 3/2. And since the original slope is positive, we're going to change that to the opposite sign, which is negative. So the slope that interests us is negative 3 over 2. That is the perpendicular slope. The next part is to determine coordinates of B so that the line EG is perpendicular to EF. Now, this point G is anywhere on this line right here. So even your book says that this is the point, but actually really it's any point on this line. And we'll find, at least one of these points. So take a look at your slope. Your slope says that we have to go 3 units down, because it's -3, and 2 units to the right. So from this E point, we'll travel 3 units down, 1, 2, 3, and 2 units across. That's one possible G value for us. That G value has a coordinate of 4 and 0. But also, we could do the opposite. We can travel up from E by 3 units, 1, 2, 3, opposite to the 3, but now we're going to travel 2 units left, 1, 2. So another point on this graph is 0 and 6. That's also a possibility. And that's your example 3. Let's take a look at our last example. ABCD is a parallelogram. Is it a rectangle? Justify the answer. Now the idea of a parallelogram is that the opposite sides are parallel. That means those slopes NB are equivalent. So slope AB and DC is equivalent, as well as slope AD is equivalent to slope BC. The opposite sides are parallel. So we know that. The definition of rectangle is that those lines have to be parallel, the opposite sides, but also the angle between them have to be 9 degrees. That means line segment AD has to be perpendicular to line segment AB. That's the definition. So AD has to be perpendicular to slope AB. And from the picture, we can find the slope. So let's start at A, and then we'll go to D. So let's just count. We'll have to go 2 units across, and so that's 2 units across. 2 units up, and 1, 2, 3, 4, 5, 6, 7, 8 units across. So that means the slope of AD is rise over run. That means 2 units up and 8 units across. 2 over 8 is the same thing as 1/4. Now what about slope AB? Well, slope AB, we will go down 2, 3, 4 units down, and we move 1 unit across. So 4 units down and 1 unit across. But since we're moving downwards, it's going to be -4 over 1. So are these two lines perpendicular? Well, are they negative reciprocal? The answer is yes, they are. You could double check by multiplying them together, and if you multiply perpendicular slopes together, we should get negative 1 as the answer. And we do, because 1 times -4 is -1, and -4, and 4 over 4 times 1 is 4, and -4 over 4 is -1. And they're also negative reciprocal. That means 4 over 1, or 4 change interplaces with 1, or reciprocates, and originally the slope is positive, now it's negative. So now we know that line segment AD is perpendicular to line segment AB. And since they're perpendicular, one of the segments is perpendicular, then all the segments must be perpendicular that we discussed. And this concludes our lesson.